Okay, good afternoon. So if you remember, yesterday we started the topic of quadratic functions. I emphasized that this topic, quadratic functions, is different from quadratic equations. There are some relations between them, but they are different things. Okay, let me also add one more thing to this list. 7, we can talk about zeros. Okay, so these are the questions that you should be able to answer for any quadratic function like this. A function which has this form is called a quadratic function. Of course, the criterion is that a is not zero, because if a is equal to zero, then this becomes a straight line. And then if a is not equal to zero, then I have a quadratic function. The quadratic function, the graph of a quadratic function is a curve. We studied a little bit about that, and then there was the name. What was the name of the curve? You remember? It's important to know. It's also the Swedish word is the same. It's parabola. So that curve, which is related to the curve of a quadratic function, is called a parabola. Yes. Okay, so you should be able to answer. If I give you a function, a quadratic function, you should be able to immediately answer these sorts of questions regarding that function. For the domain, the answer is always the same. What's the domain? The domain means, so if you want to imagine this function is a machine that you send x inside, and then it will give you ax squared plus bx plus c out. This is how you imagine this function. And when I say the domain, it means I am interested in the collection of all possible inputs that I can send to this machine, and it is sensible to my machine. Okay? So is there any restriction for the numbers that I can send in? Is there? No? So there is no restriction. So the answer to this question is always the same. Yes? So the domain of this is the set of all possible numbers that you have. But in order to answer these range, turning point, is it a maximum or a minimum, symmetry line, sketching, we have to know this method that I want to describe. We started yesterday, and that's the completing square method again. But for zeros, the answer is also the same. This is the only time that you have a relation between this function and the quadratic equation. If I want to find the zeros, what do I mean? Finding zeros means you have to imagine like this. The question is that what should I send in so that the output is 0? If you find those x's are called the zeros of your function. So for example, if I have a simple function f of x equals to x squared minus 4, if I ask you what are the zeros of this function, the answer is that you ask yourself what x should be so that f of x becomes 0. So what happens? F of x is x squared minus 4. I want to ask myself what values of x makes this 0, and then x squared becomes 4, x becomes plus or minus. So these two numbers, plus 2 and minus 2, are called the zeros of this function. So this is a relation between a quadratic equation and a quadratic function. In order to answer zeros of a quadratic function, you have to solve a quadratic equation. But there is some relations between them, but they are totally different topics. Okay, so in order to answer the rest of it, let us try to solve one example myself again. I start with the simple one. Not very simple one. The simplest one was y equals to x squared. That was very simple. But let me start from here. So I give you a function f of x. I give you, for example, x squared minus 10x minus 10. Okay? So and I want to answer those questions up there for this function. This is a quadratic function, yes? Do you agree? If I ask you what a is, what is the answer? What is a? It is 1. What is b? Minus 10. And what is c? minus 10. Yes, so that is exactly a quadratic function. If you compare this one with the blue one up there, you can immediately realize that's the case. Okay, so you need to make it a complete square. Of course, you know that this is not a complete square because I need two squares. X squared is a square, I agree, but minus 10 is not a square. So this is not a complete square in its own right, yes? So you have to extract terms from it so that you can combine them as a complete square. And this case is not hard at all. So do you have any clue? So what should I do? X squared and minus 10x. Momentarily don't see this. What do I need to make this the answer? Do you see x squared? Let me write it here. X squared minus 10x. In your head, ignore this constant number. You face this one. What is this number so that I can write so that the whole combination becomes a complete square? We have the rule of thumb. That is exactly the same rule of thumb that we had before. Do you remember what was the rule of thumb for this? So, okay, if you have forgotten the rule of thumb, you should be able to answer that. What number should I put here so that this, and that number that I propose together form form a complete square? That's what we're looking at. Say something, yes. What is that number? 25, yes. So that is 25. What was the rule of thumb? Do you remember I told you divide this number by 2 in your head and square it. This number divided by 2 is minus 5, and you square it to 25. So that's the answer, yes? So in order to have a complete square, what do I need? I need 25. But unfortunately, this is not my 25, it is minus 10. But it is easy to compensate for that problem. How? I will continue and write the 25 that I need, but I cannot change the original problem, yes? I add 25 to compensate for this addition that I don't have it. I subtract it immediately as if I have done nothing. Yes, because 25 minus 25 is 0. But then, of course, I have, yes?
It's supposed to be 35
Why?
because it is minus 10 plus
No, I'm talking to you. Yes, yeah, I agree with you. That I don't, when I am teaching, I have to give a method. I don't want to shut your creativity down. If you understand what is going on, you don't even need to have the rule of thumb or whatever. If you discover what to do, that's okay. But this method that I am presenting here, it always works. So you see, I added 25, and I immediately take it off so that I don't make mistakes. But then I see I have a minus 10 left, so I will write it down. So this is the only thing that you need to understand. So you add 25, but 25 is not there, so you have to take it off, and then you have minus 10. I copy and write it there. You might say, why did I do that? But it seems nothing, but it is something. Why? Because now these three, what can I write for those three? X minus 5 to power 2. So this one and that one and that one are now combined into this. But two more things are left for me, these two. And now that is exactly what Omar said. It becomes what? Minus 35. But you don't have to do this part. If you can jump from this to this part, just do it in any way that you like. So that is the complete square method here. So whenever you want to answer the rest of those questions, range, turning point, or sometimes people call it extreme points, if you want to know if the extreme point is a max point or a mean point. So do you remember we have two types of parabolas in this course? One parabola opens up, one parabola opens down. In this case, the turning point is a minimum. In this case, the turning point is a maximum. Okay, so that's the first step. So if you don't mind, let me write f of x here again and put it in a box and try to answer all other questions using this. Okay, so what about the range? What is the range? And by the way, so we can write y. F of x is y in mathematics. And then when I say range, I am interested in y values. So can you tell me what can I say about y values? So the y value is x value minus 5 to power 2 minus 35. Okay? But for example, you see that this expression, because of the even power, cannot be negative. So there is a minimum to it. What is the lowest possible value that this can attain?
0.
0. And when it attains 0, when x is 5. So you see, if I put x equals to 5, then this expression becomes 0. If x is not equal to 5, even if it is negative or positive, it doesn't matter. I raise it to power 2, it becomes bigger. So the lowest value of this expression is 0. So this expression is greater than or equal to 0. What the value is, I don't know, because I don't know x. But I know something. Whatever x is, this expression is at least 0. It cannot go below 0. But can you tell me what happens? What can I say for the whole expression then? This is greater, so this is greater than or equal to what? Minus 35, yes? Do you agree? Because minus 35 is there, you are adding something non-negative to it. So it means that you are making it greater than minus 35, yes? No, it doesn't become 0, but 0 is one possible value. If I choose x to be, if you ask me what the value of this, I cannot answer because I don't know what x is. But x can be any number. Why? Because the domain is R. But I am telling you, even without knowing what x is, I am sure that this part of the expression is at least 0. It cannot go below 0. Why? Because whatever this number is, I am raising it to power 2. If the number here is already positive, when I raise it to power 2, it still becomes positive. Even if this number is negative, but after raising to power 2 again becomes positive. So in both cases it is positive, and in one special case, if x is equal to 5, it is 0. So this expression, regardless of the value of x, is either 0 or greater than 0. So then it means that the whole expression is greater than or equal to minus 35, because this is a positive number. I am adding to minus 35. I am making it bigger. Is that right? Okay, so when you have this, then you can answer a lot of questions there. So the range. So if I want to answer the range, what is the range? The range means all possible y values. I got them. What are they? Y is greater than or equal to minus 35. So this is the answer to the range. Yes? And then what is the other one? Turning point or the extreme point, maximum or minimum. Okay, first of all, do I have a minimum for y or do I have a maximum for y by looking at this? Is minus 35 the minimum possible value for y, or is it the maximum possible value for y? You are telling that y is greater than or equal to minus 35. So what does it mean? Is it minus 35 the minimum or maximum? No, be careful. You are saying that y is at least minus 35 because it is either minus 35 or greater than that. So minus 35 is not the maximum value. It is understandable or not? Yes or no? Hello? Yes. So y is greater than or equal to minus 35. It means this is the minimum value for y. Yes or no? Do you understand what's going on? So say it strongly. Yes? Why? Okay. So this is the minimum value. For example, if you know y is less than equal to 5, then 5 is which value for y? It is the highest possible value. In this case, this 5 is the maximum for y, but in this case, this one is the minimum value for y. Yes? Okay. Now, what is the turning point? The turning point is the point that you reach to the minimum or maximum level. So, when do you think I reach to the minimum level? The minimum level is minus 35. But in order to reach to the minimum level, what should I choose for x? 5. Because if I choose 5, then it becomes 0, then y becomes minus 35. So in order to reach the minimum level, I have to choose x to be 5. So this means that the turning point is equal to, because when you say a point, it means you have x coordinate, you have y coordinate. The y coordinate is minus 35, but what is the x coordinate? 5. What type of turning point is this? It is a minimum point. Yes, because we learned that minus 35 is the minimum possible value. So this point is not a max point, it is a min point. Yes? So you see, we learned how to answer this. We also answered number 4. Is the turning point the max point or min point? We answered that. What is the symmetry line? Do you remember? Any parabola in this form or in that form, it can be divided into completely two symmetric parts. The line that is cutting the parabola in two symmetric parts, that is called the symmetry line. And one thing is clear, the symmetry line always passes through the turning point. Even in this case or that case, it doesn't matter. So this is a vertical line that passes through this one. For example, let me ask you one question to make sure that you remember this from Math 1C. So if I give you this point to be with coordinates, I don't know, let me write 3 and 4. Okay? If I draw this vertical line, can you tell me what is the equation of this red line by having the information on this picture? Thank you very much. Tell something, yes? What is the equation of this?
Y equals to 3.
No, y equals to 3 is horizontal. No, y equals to 3. So if y equals to 3, y equals to something is horizontal. X equals to something is vertical. Why? You don't need to memorize, because every point that you see here, what can you say about these points? What they have in common? The x coordinates of all those points are the same and equal to 3. So you say x equals to 3. And if I want to draw a horizontal line from here, what does it mean? It means that the points on this line have some property in common. What is that property? Y is equal to 4. Okay? So now let us go back here. I know my turning point, and I know the symmetry line is supposed to pass through the turning point, and it is vertical. Okay, don't disappoint me, please. Okay, so what is the answer to number 5? What is the symmetry line? Number 5? X equals to 5. Yes, because that is the turning point. If you want, you can imagine it like this. I don't know, because minus 35 is a big number, but let us say here is 5. Sorry, here is 5. And here down there is minus 35. So this is my turning point. Yes? And then the symmetry line is a line that passes through the turning point vertically. So the answer to this part is just simply x equals to 5. Yes or no? Okay, and then we want to sketch the graph. For sketching the graph, I would recommend you to do this. Only 3 points, because we want to sketch. We don't want to draw it very perfectly. So I would write x and y. One possible value for x is this number 5. And I know that if this 5, this is minus 35. Then I recommend you to do this. Put a number bigger than 5, for example 6, and put it, so how much is the difference? 1 unit. Go 1 unit to the left. It becomes what? 4. And put these numbers in your equation to see what happens. For example, I put 6 here, but instead of putting it here, which is harder, I put it here. So 6 minus 5 is 1. 1 to power 2 is 1. 1 minus 35 is 30 minus 34. You don't need to calculate this, because that is the symmetry line. If I go 1 unit to the right, the answer becomes minus 34. If I go 1 unit to the left, the answer exactly becomes minus 34. If you don't believe it, you can check it. Put 4 here. 4 minus 5 is what? Minus 1. But minus 1 to power 2 is again 1. 1 minus 35 is again minus 34. So if you want to sketch the graph, the middle point, it is better to have it as the turning point. Find that, and then go 1 unit to the right and 1 unit to the left. So let me draw it better for you. So you don't have to, because I want to sketch, so you don't need to be very precise. So what you do, you take 5, let us say this is 5, and then let us make it a little bit bigger. So here it is 5, and then let us say that here this down there is minus 35. So this is your turning point, and you know that turning point is a minimum type, so it should be of this type here. And then the other point is 4 and minus 34. So let us say this is 4, and then minus 34 will be somewhere here. So this is your another point, and the other point is 6 and minus 34. Yes, so it is here. So that was not very good. So this point and that point and that point. So you just connect them and then continued. Okay, but of course, usually it is better to find these two numbers that they are cutting. Those are called zeros, yes? So can you tell me what are those values exactly? Because sometimes it is not a good number to answer them. So that is enough if you want to sketch it. But can you tell me how can I find these numbers exactly? Yes? Yes, you need to ask yourself when the height becomes 0, because y is the height. You want to make the height 0. So it means that you have to solve this equation, but this is a little bit unfortunate equation because you can solve it. It is not hard, but it is not a very good friendly number. If you want to solve it, let me do it fast. You use ABC formula, it becomes 10 plus or minus this to power to 100 plus 140 and then divided by 2. So these are not friendly numbers, you see. So one of them, the one here, is 10 plus the square root of 140 over 2. The other one here is this number. So the other one there is what? Negative. So it is not a good picture. It should go here and then connect it here. Okay, can you tell me what is here? This is not hard. What is that number? That is a matter of seconds. Minus 10. Why? Because here, this is the intersection between the parabola and the y-axis. Yes, the y-axis, every point on the y-axis, x is equal to 0. You put 0 there, and you get minus 10. So that point is simple. It's exactly minus 10. Yes? Okay, any questions? But there is some, of course, this can be harder, not because the topic is different, exactly like quadratic equations. I can make it harder by putting a number here. And it becomes a little bit different if this number is negative. Okay? And we want to practice on that. Do you have any kind of questions? I'm not saying that this might be 100% clear. The next example makes it more clear. But is that understandable, more or less? Yes? That is the thing that you should be able to answer about a quadratic function. Okay, so let me try to change the function. I want to wait for you. I don't want to increase the level of difficulty. I want to make sure that first you understand this, and then we increase the level of difficulty a little bit. The difficulty is just algebra or arithmetic. It's not difficult at all. So let me write another function here for you, and I want to wait for you. So f of x is equal to x squared. So let me write plus. So let me make this one negative this time. That one was negative, so let me take this one positive this time. So let me write plus 8x and then plus 1. That's good. Yeah, try to answer those questions. The domain is of course always R. Find the range, turning point, maximum symmetry line, sketch the graph. All of them depends on completing a square. So when you do that, then automatically you actually know how to answer the other parts of the question.
Friendly number.
Let us try to solve this problem. So what we should do, uh, of course, the domain is always R, so let us not bother about that. So we complete a square. So I ask myself, what do I need to make these two a complete square? I need which number? What's the number? 16. So what I do, I add 16, but I just cannot add 16 unless I subtract it, and then I have a 1 there. Okay? So then I know how to collect these three. It becomes x plus 4 to the power of 2, and then this becomes minus 15. So this is your y. Okay? Now write the range. So be quiet, please. Let us focus here. Hello. So what is range? What is range?
Possible outcomes.
So okay, what should I write for the answer? Again, this is a non-negative number. I am adding a non-negative number to minus 15. So it is clear that the range becomes bigger than or minus 15. So that's the range. How many of you got this answer right? Okay, good. And then the second answer is the second one is the turning point. The turning point or extreme point. What is the turning point? The y coordinate is this number that you got. But when it is achieved, you need to go back here and ask yourself when it becomes minus 15. It becomes minus 15 if I can get rid of this. How can I get rid of this? By choosing x to be minus 4. So that's minus 4. But now, is it a minimum or a maximum? Minimum, because this is the minimum possible value. So it's a minimum point. Yes? And now the next question is that what is the symmetry line? You can immediately answer. So symmetry line, very simple. Is this now x equal you? Some people write minus 4. Minus 4 is not a line, it's just a number. When I write a symmetry line, you have to write x equals to minus 5. Be careful about that. Yes.
How can you get maximum?
There is no maximum here because is there any maximum? No, because you see that y starts from minus 15 but can go as big as you want. So there is no upper bound for it. So people sometimes say the maximum is infinity, but infinity is not a number. But some other ones, I will tell you how. If this is a negative number, then you will realize then I will have a maximum. I will talk about that. Okay, so what is next? Zeros and the graph. Let us find zeros if you want to, but zeros are simple. So what should I do? To find zeros, I need to put this function equal to 0 and ask myself what that answer is. So it's x squared plus 8x plus 1 equals to 0. And you know what to do, okay? So x becomes, I hope that you have the formula. It's minus b plus or minus square root of b squared, which is 64, minus 4 times this times that is 4, divided by 2 times that is 2. And this is not a friendly number, but you just keep it like this. I want to teach you how to simplify this. If you can, sometimes you can simplify this more, because the square root of 60, you can write it as the square root of 4 times 15. The square root of 4 is 2. Okay? If you insist, of course, I want you to learn this. Instead of this, I can write 2 square root of 15, and then I have 2. But between this one and that one, I can factor a 2 out. It becomes minus 4 plus or minus the square root of 15 divided by 2. This 2 and that 2 are gone. So if you insist to make it more beautiful, you continue up to here. These two numbers are the zeros of the function. But if you don't want to simplify it, you stop there. So both of them are acceptable. Finally, if I want to sketch the graph, what should I do? I set up a table, x, y. The middle one is that point, turning point. It's minus 4, minus 15. And I told you, add 1 unit to it, it becomes minus 3. Subtract 1 unit from it, it becomes minus 5. And calculate one of them. So you put it back here. If I put minus 3 here, it becomes 1. 1 to power 2 is 1. Minus 15 is minus 14. And if you haven't missed that calculation, don't doubt. This also becomes minus 14 because that's the symmetry line. Yes? And then you find these 3 points and connect them. So I don't know, for example, here, this is minus, let us say this is minus 4, and let us say this is minus 15. Okay, so minus 4 and minus 15 is here, and then minus 3 and minus 14, this is minus 3, for example, and this is, for example, minus 14. This is another one, and the other one is here, minus 5. Okay, and then you have these points. This is a sketch, of course, but if you want to make it precise, do you think it will go and cut the y-axis at some point? Yes, where is that point? How should I know where the intersection with the y-axis is? It is very simple. If you want to find the y-intersection, you put x equals to 0. You get 1. So if it goes up, it will cut this at 1 and goes up. And this number and these number you see here are the zeros, or these not very friendly numbers. You see one of them is positive, both of them are negative. Minus 4 plus the square root of 15 is negative, minus 4 minus the square root of 15 is also negative, and it is clear, both of them are negative. That's the sketch of the graph. Okay, now let me give you another example that this time we have a maximum. Then you will see why we should have a maximum. Okay, I will solve the first one myself, and then I will give you the chance to solve the other one yourself. Again, I don't want to make it harder. I just choose this function, another function like this, but I put a negative 1 here. So let us write minus x squared plus 4x plus 7. Okay, we want to answer the same questions for this function. I want to emphasize what is the main difference. The main difference is this negative sign. The other negative signs were not that important. You remember we had negative signs here. That was not that important. But this negative sign is important. Okay, there is only one more step you have to do. You have to pull out the minus sign first. So what you do, you pull the minus sign out. Let us see what happens. This becomes positive. This becomes negative. Okay, and this also becomes negative. Okay, listen, hello. Okay, so if this is minus, you pull the minus sign out and do the same thing. Pretend that there is no minus sign. Pretend means copy and paste it every time, but don't let this bother you. So what do you do here? Do you remember? You add a number. In this case, the number is 4. Yes? But you immediately take it off, and then you write minus 7. You see, I am just pretending as if this minus sign is not there. So it becomes minus. This part becomes what? X minus 2 to the power of 2. This one becomes minus 11. Now this time, this is finished. In the previous step, this was finished. Now multiply the minus sign back in. And then this becomes positive 11. This becomes negative x minus 2 to the power of 2. Yes? This time, this is again non-negative. Because that is an even power. But look, what is happening? I am taking this positive number from 11. So if I write this, I hope that you are not happy with that. Can I write this? No. Why? Because this time 11 is here. I am writing 11 minus a positive number. 11 minus a positive number cannot be bigger than 11, but it can be what? What? Smaller than 11. Yes? Well, that's the reason. So here, the y value is less than or equal to 11. This is the range. If y is at less than or equal to 11, is 11 maximum value or minimum value? Maximum, because you are telling y is at most 11. So this is maximum point. Okay? So then you would say the turning point, which is the extreme point, is equal to the y value is 11 again. When 11 is achieved, when 11 is achieved, when? No, when 11 is achieved, it means when what should be x so that I go to 11? 2. If I put 2, this completely goes off and I am left with 11. So x should be 2. But is this turning point a max or a mean in this case? It's a max. So it is a max point. Yes? Okay? So I was able to, but then the rest of it is more or less the same. Symmetry line. What is the symmetry line? Symmetry line is what? You need to write x equals to this number. If I ask you what are the zeros, zeros is just the quadratic equation. You can solve it for, and then we can sketch it. Okay, so what are the zeros? The zeros is that what is x so that f of x is 0. But then I have to solve it. So it means that minus x squared plus 4x plus 7 is equal to 0. How should I solve it? A is minus 1, B is 4, C is 7. So let me just review again. This becomes, the discriminant has this formula, so this becomes 16 plus 28, which is 44, and then x becomes a minus b plus or minus the square root of 44 divided by 2 times a, which is minus 2. You can keep it like this, but I always prefer to simplify as much as I can. So I write minus 4, square root of 44 can be viewed as 4 times 11. Square root of 4 is 2, square root of 11. So I would write minus 2 plus or minus 2 square root of 11 divided by minus 2. I can factor a 2 out, divided by minus 2. Well, this 2 and that 2 are gone, minus 1 is left. So it becomes minus 2 plus or minus the square root of 11. And I multiply the minus sign in, it becomes 2 plus or minus the square root of 11. You don't have to simplify if you don't like it, but anyway, these are the zeros. So the zeros are what? 2 plus the square root of 11 and 2 minus the square root of 11. These are the zeros. And now if I want to sketch it, you see what happens. You find the table again as before. Again, this point is your turning point, 2 and 11 in this case. Add 1 more to it, subtract 1 from it, and then put these numbers in your function. I think it is simpler to put in the last 4. So if x is 3, this becomes 3 minus 2, 1. 11 minus 1 is 10. Don't doubt, this also becomes 10. But be careful in sketching. Here, this turning point is not a min point, it's a max point. So how should I draw that? So I have, let us say this is 2, and let us say this is 11. Okay, 2 and 11 is my turning point. And then I have 1 and 10. Let us say this is 1 and this is 10. This is 1 and 10. And then I have 3 and 10. Then you see that this is the turning point and these are the points. So automatically you understand that you have to draw it in this form. And then you continue. If you continue, it will go down and intersect the x-axis as these 2 points. Is this number positive or negative? It is negative. So it will pass, before coming down, it should pass here, you know, and then it goes like that. You don't have to be very careful here. But what is this number here? Can you tell me?
Which one?
This number here. This number here is the 0, 2 minus square root of 11. This number there is 2 plus square root of 11. But what is that number?
2.
I put x equals to 0. No. X equals to 0, it's 7. It's a very bad picture, but this number is 7. Okay, let us do it with GeoGebra to make sure that we are doing everything right. Okay, so let me type that function. What was that? Y equals to minus x to the power of 2. X to the power of 2, and then plus 4x plus 7. Am I right? Yes, so that is the function. So when I type it in GeoGebra, I will get this picture. So let me make it sure that you understand it correctly. So you see, the highest point, the turning point, is 2 and 11, exactly according to our calculation. And you know that GeoGebra is capable of giving you the extreme points. You go here, extremum, you choose this one, and click here. It gives you the vertex. Vertex, by the way, this is why they call it vertex. If you have a triangle, those corners are called vertices, vertex, okay? Vertex, if it is a parabola, this point is also called a vertex. But in our lesson, we don't call it a vertex, we call it a turning point or extreme point. Okay, so now you see my prediction was correct. That was, my picture was awful, but this number is exactly as I predicted, 7, yes? So here you see, I told you this is 7. It is always possible. It's very simple to calculate the intersection with the y-axis. Why? Because if I want to find the intersection with the y-axis, I just put x equal to 0. Whatever I get, that is that number. So when I put 0 here, I get 7. So that should be 7, even though the picture was not anticipating this, and that is because my picture was really terrible. Okay, if I ask you what are these numbers, there is also an instruction in GeoGebra. So you go to GeoGebra and you find roots. In English, they call it roots. In Swedish, we call it zeros or några ställen. So you just click on roots and then click on this, and it will give you these 2 points. And these 2 points are minus 1.32 and 5.32. Let me calculate my numbers there. One of my numbers is 2 plus square root of 11. Let us see if I have correctly calculate that. Yes, it is 5.32. And the other one is what? 2 minus square root of 11. And then if I press enter, and that is minus 1.32. Of course, these are approximate values, the values that I got. When I ask you find zeros, you have to answer with this 4, not decimal points, unless I mention that I want you to answer it with decimal points. So is that clear, everything what we have done? Yes or no? Okay. So I don't know if I record that part or not, but let me increase this number. For the time being, let me keep it. No, let me give you one example with negative minus 1. I want to make sure that you understood it. Okay, so let me write this one for you and wait for you. We are not in a hurry. So f of x is equal to, so this time let me write minus x squared minus 6x plus plus 6. Okay, I want to wait for you. Okay, should we start? So why this is the new lesson here? Because I see a minus sign here. So the first thing we do is what? To pull it out. When you pull it out, it becomes positive. This also becomes positive, but because this is already positive, now it becomes negative. And what you are supposed to do is just momentarily ignore this minus sign and try to do the same trick as before. So which number is needed? Which number? I need to add which number? So that means 9. But when I add 9, I immediately take 9 out. It's here. But then you know what to happen, what is happening. So I would write x plus 3 squared. But I have a minus 9, minus 6 is minus 15. But then you multiply the minus sign in. When you multiply the minus sign here, the first one becomes positive. This one becomes positive, this one becomes negative. Yes? And then you already know, because of this even power, this part is non-negative, but you have 15 and you are taking a non-negative number from it. You are taking a positive number from 15. So what happens? It goes below 15. Below 15 means that less than 15. Yes? That's it. So if I ask you what the range is, so what is the range? The range is y less than or equal to 15. When you say less than or equal, so the turning point is what? The turning point is the y value is 15. The x value, you go back here. For which value of x I reach to 15? Minus 3. But what type of turning point is this? Because this is the highest possible value for y, it means that I have a maximum. So that's the max point. So remember this, whenever this sign is negative, definitely the turning point is a max point. And then the rest of the questions are simple to do, yes? So what can I do now? I can say so the zeros, for example. The zeros are simple. I have to put this equal to 0 and solve it. So it becomes minus x squared minus 6x plus 6 equals to 0. So let me do it fast, because I hope that you have the formula in your memory now. So minus b is 6 plus or minus the square root of b squared is 36. Minus 4 times that, positive 4 times that is 24. And then divided by 2 times this, which is minus 2. So it is 6 plus or minus, that number becomes what? 60. Divided by minus 2. These are the zeros. If you insist to simplify, we can. Because 60 can be viewed as 4 times 15, but the square root of 15 is 2. Sorry, the square root of 4 is 2. So I can continue if I want to. The numerator, I can pull a 2 out, so it becomes 3 or plus or minus the square root of 15 divided by minus 2. These 2 and 2 are gone, minus sign is left, so it becomes minus 3 plus or minus the square root of 15. And multiply the minus sign, it becomes minus 3 plus or minus the square root of 15. So these are the zeros. And if I want to sketch it, so I have x and y. The turning point is this point, minus 3 and 15. So I told you, go 1 unit higher, it becomes minus 2. Go 1 unit lower, it becomes minus 4. And calculate only for one of them. If you don't make mistakes, the same numbers will appear here and there. So for example, I go back here, I put minus 2 plus 3 is 1. This becomes 1. 15 minus 1 is 14. Definitely, this also becomes 14. You see, if I put minus 4 plus 3 is minus 1, minus 1 to power 2 is still 1. So 15 minus 1 is 14 again. And then I can sketch the graph. So what is minus 3 is, let us say this is minus 3. Oops, it's not a good place to start. So let me just draw it here. So it is minus 3, minus 1, minus 2, minus 3. But 15, let us say 15 is here. Yes, and then minus 2 and 14. This is minus 2, and let us say 14 is here. and then minus 4 and 14 again. So it's minus 4, let us say this is this point. So this becomes that. Okay, if you want to make it more precise, can you tell me where this intersect the y-axis? It comes down. So you can check what is happening. You see, both zeros are negative. Minus 3 minus the square root of 15 is negative. Minus 3 plus the square root of 15 is also negative because the square root of 15, no, sorry, square root of 15 is bigger than minus 3. Yes. It is, one of them is positive, one of them is negative. But where this is the intersection point, you put 0 here, it becomes 6. So down there should be 6 here. So it should go from here, yes? And then it will go there. So this number, if I ask you what that number is, the positive one of the zeros. This is exactly this number, and if I ask you what is this 0, it is minus 3 minus the square root of 15. That's a sketch of your function. Is that right? Yes.
Did the range explain why it became less than?
Because this is 15 minus a positive number, so it goes below 15. Yes, in the previous cases, if I have this plus x plus 3 to the power of 2, then I am adding a positive. This is positive because of even power. If it is positive, it means that I am adding something to 15. It goes beyond 15. But if it is negative, it goes below 15. Okay. So then it becomes less than 50. Yes? Stop here. So, but it is not finished because now I want to increase this number to higher numbers, 2 or minus 2, 4 or minus 4. But that also needs explanation, but I think you are a little bit tired now after a long discussion today. So I will postpone it for Wednesday. And on Friday, we will have more interesting problems. You might say, what is the application of this? Why we are learning this? But there are some good problems in the book that tells you why it is good to maximize or minimize a function in general, why we are interested to find the maximum and minimum of function. Of course, you will study it better in Math 3C under the title of optimization, but we also learn something in this course as well. Okay, the lesson is not finished yet. 15 minutes is left, so please try to work on yourself. Don't waste your time. Thank you.